Okay, so Figure AI just knocked it out of the park with their Helix AI-enabled bot demo. And if that were not enough, they've just released a really impressive demo of Figure bots on a sorting line. This is for their second customer, I'm told, yet unnamed. So what's the excitement all about? Let's break it down with the star duo. Scott Walter is a mechanical and aerospace engineer and two-time founder of robotics companies, and Gustav Andersson is a hand surgeon, and he's joining us from northern Sweden. Well, welcome, the star duo. It's great to have you back. Lots to talk about. What do you make of this?
So, I think the first thing is that what most people will notice with what's going on there is it seems like it's a really simple problem. And the thing about it is that sometimes these problems that are really simple turn out to be really hard to automate. And this is known as Moravec's paradox, that things that are easy for people are hard for machines, and things that are hard for people tend to be easy for machines. And what's going on here? So what's big about this is that it took Figure a very short period of time to get the bots doing it. It's using pure end-to-end. And even they were amazed at how quickly they were able to get the bots to figure out this problem just through some simple demonstrations. Now, what's going on here is this is not at the customer location. This is in Figure headquarters, where they, basically rebuilt the line. This is what they would call like a triage on the sorting line. So all these packages just get piled on a conveyor. And in order to do the sorting, the proper sorting, you need to be able to read the barcode. So all they're doing is making sure the package is facing the right. It doesn't matter which package they grab. They're just like, look, we're just trying to do it. We need to have enough of them in there to make sure that the bot at the end isn't being overwhelmed. So you're pulling off like 25, 30% as you can and moving around. And it may seem like, well, that's really simple. You should be able to automate it. The thing is, not only are the locations of all these packages random, position orientation, but they're also made out of different material. You can't control the type of material. So there are a lot of sorting lines that work very effectively because they're able to control the kinds of packages that are going on there, and suddenly some sort of end-of-arm tooling like a vacuum gripper works perfectly. But then there are things that vacuum grippers don't work with, that you got to use like a mechanical gripper. But then there are other, so you have all these things. And it turns out, if you want to design a universal gripper, it looks like this. Okay. And that's part of the point. And the other is being able to do it. So it looks dead simple. A lot of people think, look, you just be able to get off the shelf 2D camera, and with a lot of vision systems, you'd identify those things. It's like, yes, there are a lot of systems that have been doing that for decades now, that can actually hunt, their prey, and a bot will go over and pick it. And usually it will be like chocolates coming down a conveyor line like that, where they're picking up the chocolates and putting them into a box with high precision and everything else, because it's just chocolates of the same size and similar shapes and material and properties that are coming on down there. But when you come into these logistics situations, it's just so random. And even Amazon, when they try to do something like this internally, they standardize the packages that things are supposed to go in, so that their automated sorting lines will be able to work. So if this was so easy to automate, it would have been automated by now. And the companies that are doing this are employing thousands of workers to do this. And of course, you can imagine that after doing that for a couple of weeks, you might reconsider your career choices.
Okay, so this mystery customer, before we go on to you, Gustav, do you want to give us any hints? Scott, the USPS, could it be, or Amazon, or one of the big other warehousing companies?
It's a very large logistics company that has, that employs. I do not know who it is. It is kind of a mystery. There is a lot of speculation on potentially who it could be, but it's clearly a company that is not going to be buying just a dozen of these, not going to be wanting a couple hundred of these, but in the thousands.
Wow. Gustav, your first
I was just thinking that the hand movements and the use of their grippers seem to be quite efficient. I mean, we looked at the NeoGamma hand the other day, which had issues picking up the phone from the table. Here, there seems to be, at least in this video, no qualms about picking things up. So that's impressive. And also the depth of view that they have with the stereo cameras. It's good that they get this going. And there is no LiDARs or anything else required, just pure stereo vision.
Exactly.
In terms of of degrees of movement and the ability to flex, do you see any difference in the hand whatsoever? You know,
Well,
what something that stood out to me that was, I don't know, it just stood out was the little backflip that they did to get those packages moving on the line that's perpendicular. There you see the side flip, but then you see a different view where the bot's standing facing the main conveyor belt, and there's a little backflip that it does to push it along, which is
yeah,
very
kind of
interesting, I
behind
thought,
it.
because that was almost human in the
Yeah,
way they did it.
and a little bit out of sight. It's we don't know the peripheral vision of these, but
Right.
uh,
And,
and it,
and part of
Very
it
good.
is, remember, is this is coming from human trading data
yeah,
telerobotically. So if there are some human nuances, because that's kind of in the training set, and they did go through and call
That's it.
out some of like the bad examples, but they
Mhm.
said the examples where it had to do like a repick or something like that, they put them in there because it was very important, because every now and then you're going to fail, and it was able to do the error recovery. That's very, very important to be able to do that.
and they more or less handle two packages at a time. It's not just one at a time that they finish. They kind of picked one up while the other one is being pushed away. So it's not a very advanced hand movement. I mean, they grip and they push, but definitely it's good enough for what they're doing. And as you
It's good
mentioned, there
enough.
are
Yeah.
very different packages. It's boxes and small bags and big bags. So yeah, and there is no real sensory feedback in these aside from maybe some coming from the actuators. But as far as I know, there is nothing in the fingertips in these
Okay,
robots.
and Scott, just to get it out of the way so that all our viewers are clear about this, this is not teleoperated at all.
Correct. They have not shown anything that's been teleoperated. All the videos they've done are autonomous. Not just this one, but if you look at a lot of the other figure bots, they're all going in an autonomous mode to be able to show that. We can see that the speed maybe it's kind of human-like. Some people say it seems like it's maybe a little bit slower. Part of the problem is the data capture rate. So they mentioned in their white paper they have a sport mode where they can actually take the telerobotic data that they've been trained on and be able to speed it up a certain amount. But it turns out you can only speed it up so much. If you try to go 2x, then the data quality is so bad it doesn't quite work right. So they can get a bit more. And the problem with teleoperation is, like, even though it's being done with the human teleoperators are slower than just a human alone, because of just the fact that you've got this telerobotic kit. Your field of view is not the same as actually being there. And so there's always like a little bit of hesitancy. And I know there's some experience because I've had a chance to actually teleop one of these bots, not the figure, but a different one. And that was like I noticed, like, wow, this is kind of hard to do. You can get the process done, but not at the rates that you would be accustomed to do if you're doing it yourself.
Yeah.
So
Yeah.
one of the challenges that I think they're all going to have is they need to find a way when they're getting the data telerobotically, how to be able to speed it up, because it's not that the bots are slow. It's just that the data that they have is not allowing them to really go at those higher rates yet.
Okay, so that's a segue to my next question, which is to what extent can this be speeded up, and
Yes.
what is that dependent on?
Yes, and a lot of it is dependent on the current rates. So, ideally, you'd like these things to be superhuman so that they would go a lot faster, and you can make the conveyor run quicker or have fewer stations or something like that. But right
And you
now,
need fewer of them.
yes, fewer of
any
them.
line.
But right now, the what you're trying to do is the benchmark is human speed. So the term is useful work. In useful work is that you're able to provide the same services as a human at the same rate, same quality, same reliability, and at or below cost. So if you can't match any of them, there's no point doing it. You're going to continue to have humans that are doing it. So that's all they have to do. It doesn't, and you could put a person there and they can be like really quick on that for 5 or 10 minutes, but they need to do that for 8 hours. So everyone has to get into, you've got to remember, this is a marathon. This is not a sprint. And throughout the whole day, you've got to do it. So these lines are all tuned to what people can actually operate at, not at what would be a burst rate or something like, every now and then you have like a burst that's going on where something got backed up and it's coming down there. Everyone tries to catch up, but then they got to catch their breath and then they get back to the normal monotony. The other thing that everyone's going to say easy is like, look, they're just pushing the thing off. It's like, no, they're not just pushing it off. They're having to flip it over. And that's actually the hard part of the automation. It's like, it's really easy to push the boxes off onto a side conveyor, but if you got to flip it, it gets a little bit trickier. And that's really the nuance on why the problem is a little bit harder than you think. Because, making the decision on whether to flip, it's not going to be that hard. Yeah, a vision camera will look at it and say, it needs to be flipped. But depending upon the object that you're picking up and what you have to do to bring it on over, sometimes it just doesn't work right.
Okay, so do you think this is ready for deployment now, or does it need to be optimized further?
It's very close to deployment. My understanding is it's going to be going out of the lab and to the customer site for testing. And then, from there, they will then get the data that they need to see the reliability. So it's getting ready to do the next. And overall, they hit these targets faster than they expected because just a little bit of data and suddenly it was working. They also discovered a few other things that have helped the overall Helix architecture. So the first one was monocular. And now, they have stereo, and it's kind of funny. They don't have your normal binocular eyes. They've got camera up here and one down on the chin. Yeah. And I'm kind of joking. I said, does that mean when it goes to the mirror, everything is reflected, the other way,
Yeah. That's an interesting choice. Do you have any idea why they did that? Is it better for lifting and handling, seeing what's upside down rather than depth?
Yeah, maybe it's just because they wanted to get a better field of view looking down there. I'm not quite sure. Having
larger distance between them gets better depth perception.
The other things part of that, but I think also there's two ways that you can do stereo. One is you can have two eyes, and one is that you can move your eyes. Mm-hmm. You can do something like that. So a lot of times through a little bit of motion, you can get this quasi stereo effect by putting it together. And all that's important is that in the end, they're able to build this three-dimensional scene that they understand. So it's still stereo, but let's say it's a little bit different than we would think it'd be done. And the other thing they're trying to do is to process the images. The synthesis that they want to do is that when you go to stereo, suddenly you have twice the amount of data that you have to process. And they've done some tricks to actually be able to fuse it together to make sure that they're not having to suddenly have twice the data that they wanted to have.
Yeah, and this video, of course, dropped a few days back, and it kind of blew our minds because of just the potential for deployment at fleet level. So here's a question for you, Scott. You have the hardware and the software, right? What's ahead at this point? Because there was always a problem of one or the other being ahead. When we saw the first demo, the hardware was way ahead of the multimodal AI, which is software. But now it seems, given the ability to coordinate and communicate with each other and kind of work together to solve problems or do tasks, it seems the software has not only caught up, but just is way advanced of the hardware.
It seems to be on par. There's like another generation of hardware that they're all working on, which I think is going to surprise a lot of people as far as the capabilities of that hardware. It's going to look similar. It's going to be improvements in the actuators, the control systems, and everything else. And in some sense, designing these things to really be meant for neural nets. Not your standard kind of control system. So they will then have that capability. In some ways, the hardware is a little bit ahead of the AI. As far as we know, the biggest thing about the hardware is going to be the robustness.
That's interesting.
Can you really put the hardware on the line and have it run 16 to 20 hours a day nonstop? Or are you going to start experiencing lots of issues?
Function of
yes.
That's the function of the battery pack, or what is it function?
Oh, the actuators. You could burn the actuators out if you over torque them or use it. So we don't know what the reliability of these systems are going to be and how much maintenance it is. It seems like they're highly reliable compared to their previous versions, which were cantankerous and breaking down all the time. So they couldn't go like an hour or two without breaking down and then someone having to fix something. Now they seem to be extremely robust in that they go days and weeks without having any issue. And that's what you want to see is what's going to be the mean time between failure on these things to get them up to that scale that you are comfortable with the deployment. So we don't know that yet. And it could be one of those things that these things run great for 3 months and then suddenly you start having all kinds of problems. And you get what I call the bot of Theseus, that you replace so many parts, like a year later, you wonder if it's the same bot. That's that's the thing. And we're going to be, I think, looking at a video later on of some of the stuff that Unitree and everything else is doing, is like this thing with the backflips and stuff like that. And I keep on telling everyone, it's like, when's the last time your job description said it included backflips? You don't necessarily want to do it. And you almost don't want the bot to do it, because you know what's going to happen between the shifts. The humans are going to come out and ask the bot, hey, show us that backflip you did the other day. And they're going to do it. And it's like, while the bot can do a backflip, I have a feeling that every time it does it, it's reducing the lifetime of that bot significantly, way more than people may realize.
So you're definitely going to need HR for a while longer, aren't you?
Yeah, exactly. So if it's out there kind of like overtaxing itself, it may turn out that these bots end up having more problems. So that's one thing you have to watch out, is what happens in the break room between the humans and the bots.
Okay, so Gustav, let's get your insights on this. When you look at the hand movements, so it's not really a super complex hand, is it? But you did say that it's sufficient to get the job done at this stage. Is there anything from your experience in terms of the human anatomy and the musculoskeletal system that perhaps could be added to get a little bit extra that will give you a lot more bang for buck? Do you see anything here?
I mean, in this type of work, I think this is evidently more than enough. You could probably use less efficient hands to do this type of work. It needs to get a good grip, a quick grip, and if it's a box or it's a plastic bag or whatever. And so it's both pushing it, so that's no problem, but it's also picking them up and handing it from one hand to another. So it's more definitely enough. So it's not really using the fingers too much. So a lot of it is in the wrist, it feels like, the gripping and then wrist motion, pushing it away. So evidently it's more than enough, I'd say. And then the question is, so what's the next application? They're already in use in the BMW plant, where they're, I guess, moving the sheets of metal, as you've shown previously, Scott. So, but yeah, as you can see, it's basically just flexing and stretching the fingers together with thumb. It doesn't really handle it in any special way, and it doesn't really need to. I guess it's the thumb who does the most varying work here, with some opposition and reposition, adduction, abduction, whereas the fingers are just there. So it will be interesting to see whether the other bots, which have a stiff CMC joint or stiff thumb, would be able to perform this. So as I mentioned previously, the Neo Gamma seemed a little bit fumbly when we saw it in this phone reveal, and I'm not sure if it would be able to perform as well in this task with that.
Yeah, that's what surprised me, is that there was a lot of things we didn't see in there. And so we saw the Gamma hand coming down and attempting to grab the phone, and the next thing we see is like it's in his hand, but we didn't actually see it picking it up. And it's really not as hard a problem as a lot of people think, because as soon as you get a little bit of lever underneath there, like, the phone just kind of pops up, you just get that other finger underneath. So you can have one. And I suspect it could be that we talked about like wobbly CMC joints, and also the fact that you have abduction. And if that's being done with tendon control, it may be that you're just not able to get that kind of strength that you need, or the opposition, and that you go to do it, the finger maybe slides and then the phone kind of twists around rather than coming up. Whereas, the figure hand is designed in a way that I think it can apply a more direct force and hold that force better, because it's more of a position control than it is a force control. And when you have tendons, it really comes down to that force control you need to have. And remember, if you can't hold that finger from doing this, it's really hard to get the strength that you need in the flexion to be able to do something. So you can overthink a hand. And this might be one of those cases where the hand is right at the level that you want it to have.
And so what I'm always a little bit impressed about with it, when it missed the bag a little bit, and it probably because it didn't exert enough force, or and I guess the same thing with the phone. We would directly feel if we're not grabbing the phone strong enough. So if it's starting to slip or getting out, we would adapt.
I mean, I'm picking it up off the table really easily in this, and it's not because I'm a human with like super dexterous hands. It's because it really is an easy problem. It's not that hard when you just pinch them and then get that little bend, and then your fingers are coming right underneath, and then you've got a full grasp on it. So I was really surprised they didn't show that with the 1X demo on that. And I'd be interested to see whether, figure would have the same problem or not. I suspect not, just because I think their grip might be a little bit stronger. They have slightly better control.
Yeah, and they just have to more or less adapt the thumb they don't have to adapt for the lateral
Yeah.
support. So it's just the thumb adapting how strong it meets the fingers in different positions. So, and also if we feel that the pen is slipping, the robots won't be able to do that possibly. So that's impressive here that unless they have some kind of force feedback that we're not.
They do have force feedback. So they know how much force they are applying that's there.
Would they sense whether or not it's like slipping? So
the slipping maybe not. So they don't. So without putting direct sense, they're not going to be able to sense that shearing. Probably not with a pen because that's very slight. I imagine if you had like a very heavy object, you might notice that something is kind of causing my thumb to want to move down. That I don't quite, because so. But you're right. You don't have that shear, which would be nice to have. So, but they can tell what the pressure is that they're putting on the pinching easily, and that comes either directly. I think in some cases they actually do have direct force control. The other, it just comes from monitoring the currents. So you have an indirect way of doing it and also a direct way.
So, and it kind of the example they've had with self-correction there, it apparently didn't get a good grip, so it dropped.
Didn't get it. Yeah. Now the other thing to talk about is like this particular application, you can make an argument. It's like, well, do we need to have that many fingers? Can we use a different hand design? Does it need to walk in there? Can it just stand there? And the whole thing comes down to is that if you just have to worry about one robot design and training one robot design and one type of neural net, it's much easier to place them in. And while it may not seem like it's the ideal configuration for that, when you start having a lot of different product SKUs, it becomes a lot harder to manage. So there's a lot of companies that are thinking about, we're going to have like all these options on there. I'm like, okay, let's see what happens. Suddenly you put a different hand on there and suddenly your training sets are useless because they were based on what was a 5-finger hand or something else. And so that's a very important thing. It's something they point out in the white paper is that they need to do this calibration to allow them to be able to update the whole fleet. Because even though the robots are, quote, identical, actually they're not. There's a slight variance in the manufacturing tolerances that can be enough to throw it off. And they have got like an advanced way of calibrating it to be able to compensate for that. That's a problem in traditional robots as well, but it's a problem of even greater magnitude for these humanoid bots that they have to solve. So they understand the problem. I understand the problem conceptually because I had to deal with that problem for decades of being able to take two, quote, identical industrial robots and transfer a program from one to another. So when you start changing your form factor to suit a particular application, it may actually cause more problems than something else.
Okay, so this is just one function, one job profile, shall we say? How big is it a challenge to take just one of these bots and train them for another job profile in the same workspace?
Like you did it really fast for this one, right? You mentioned, I don't remember exactly if it was hours or days, but compared to training for BMW, it was a huge step up.
It was much easier. And probably if they go back to the BMW, they'll find they'll be able to do that a lot quicker. So they've learned a lot in the past year on what's going on, developing this Helix system. And now the Helix system is integrating in more and more examples. So, the first ones are really hard because it doesn't know how to pick up an object, or certain types of it. But now that's starting to be in there as you go into these other applications, there's going to be a lot of crossover from those that will allow it to scale up a lot faster. And so, they're starting with a low-hanging fruit right now. And it's like a really weird kind of low-hanging fruit. It's a low-hanging fruit that no one's figured out how to automate yet. And so that's part of the reason it's there. And the same with the BMW example, that whole thing was never easy to automate either. And again, it would have been done. Guarantee everything, if it could have been automated by now, it would have been.
But do you think this type, when they did it the first time, was it like traditional object recognition that this is exactly this type of metal plate with this shape? So I should always
they were using nets. They were using, but they were using like the very early part of I don't even think it was called Helix at the point. So they were just starting to cut their teeth on the problem and understanding it, but they were doing it with neural nets, and I think they were very soon doing like end to end.
So there's no neural nets here. Is that what you're saying?
Yeah, it is. It's all neural nets. It's all neural nets. So there's none of the traditional camera systems that would go in there and object identification, convert them into Cartesian coordinates and teach it the way you would the robot. This is really going pure end to end, where the robot has seen enough examples that it can figure out what it needs to do.
Yeah, because I mean, if you have a small Coke bottle, a big Coke bottle, or you don't want to program all of them, you just want it to.
You want it to generalize.
This is a quite big one. This is quite small one. I know how to adapt my grip. That's where I think we would like to go also in prosthetics, that you could get your robotic hand to, you don't have to tell it that this is a mug or a cup glass. It just figures it out.
Yeah, again,
I think they demonstrated that the ability or object recognition ability across sizes and shapes with this video, right?
Yeah.
Yes. So it's seeing items that it had never seen before in the training set. But because of the pre-trained internet sort of LLM that they have, it was aware of what ketchup is.
Yeah.
It just hadn't picked up a ketchup bottle before. So when it picked it up, it was able to generalize, saying that, oh, this is similar to some other objects I've picked up. I know what it is, and I know where it has to go because I know it's ketchup. And the same thing with the eggs and all those. So that is like sort of the first steps you want to go through, is get enough of a generalized training set of different types of objects and shapes, but you don't have to be, specifically.
But that's pre-training, you're saying, right?
Object. Yes.
So if you break it up, out of 100% of training, that's pre-post, and then maybe a bit of reinforced or reward learning before you get on to the inference, which is another section. But just let's talk about pre-training and post-training. What's the balance that you see evolving in this use case for FigureBots?
Okay, so a lot of the pre-training can be done in simulation. So that's been done, like a lot of the robotic walking and everything. There's reinforcement learning that they do through simulation, because they can then just get the millions and millions of iterations that they need. For the packaging line, it's not so easy, because the physics of the packaging line is like really difficult. And so that was not something that they could do in simulation. That's something where the training actually had to be telerobotically, that you would go in there and the bot would be shown how to do these different cases. And the thing is, it learned very quickly how to do the job, which is kind of what we would expect. If you take a fully formed human that's able to do lots of things and they've never seen a particular task, and you bring them in, they're going to figure this thing out in half a morning, right? Or maybe even quicker than that, or exactly what it is. Eventually, you don't even have to show the human what to do. You just have to tell them, what you do is you just pull off the box, the packages as quickly as you can and make sure the barcode's up. Yeah. You would do a description. And we are seeing examples of that. There was like a paper that came out yesterday from PI, which I think it's like physics something. The PI, it stands for it, where they were doing a very similar demo where they were instructing these bots. And in this case, these were very simple, like cobots, to like make a sandwich and go and grab some items off the shelf and everything else, where they would just be interacting with and having a conversation. And the bot would say, oh, you want this and that? And like, no, I don't want that. So when making the sandwich, halfway through, it's like, oh yeah, could you add, a little bit more cheese to it, or this and that. It wasn't just a top-down instruction of like, you build this and it follows the recipe. It was very interactive. So we see that there are these neural networks out there. And if you want kind of confirmation what's going on in Helix, you can see there's someone else has done something very, very similar. So we know this is exactly where the industry is moving.
Mm-hmm.
Yeah, that's fascinating because, sorry, go ahead, Gustav.
No, just a former clip when it actually put the ketchup bottle up straight. The rest of the object, we don't really tell, and it kind of just puts it to the side. But you think it was pure luck that it happened to position it straight up? Or was that like part of, I'm used to seeing bottles stand up, but because it takes like a bag of, I don't know if it's flour or whatever it is, and then it just kind of shucks it in the drawer, whereas the ketchup, it actually manages to put upright, but it's lying on the table when it picks it up. So I wonder if that was pure luck, or if like this should stand up.
It is kind of interesting that it got it right, and especially when there was no suggestion that this is the proper way a ketchup bottle should be when it was lying on the table. So it was actually in like a more difficult position to pick it up on the table than where it ended up. But you're right. It's like, well, maybe it kind of knows. Maybe that's something that's in there. I'll have to.
What happened to the eggs?
Yeah, that's a good question. And the eggs, I think, ended up in the lower container, and they stayed flat, so they didn't get put in a strange angle. But yeah, something like that, which is squishy, we all know it's just like, oh, I don't, the best thing is for that thing to lie flat.
So that's
okay. So hang on. Just at this very point, explain it for our viewers, Scott. How does it differentiate between something that is squishy and soft and delicate and something that's robust, more robust, like a bottle? And explain the mechanism for us, because there are no sensors here on the fingertips.
Yeah, but it's basically, well, there are sensors. It's a camera, and there's an LLM. So from its vision, it can see that, not only is that a ketchup bottle, but it's a plastic bottle, and plastic bottles have these characteristics. And then if you see something else that it looks like it's made out of, a paper package or, plastic, it would kind of know, because that's inherent knowledge it has from the LLM. That's just there. So part of the knowledge that it has is that it will see certain items and classify them. So it's, I think, the training set, they showed butter, and the butter went in the fridge. And in this case, there wasn't butter, but I believe that package it was picking up, it was probably like shredded cheese or something like that. So suddenly it has to look at it and say, okay, what's this similar to what I've seen before? And it might know the classifications. It's dairy, and dairy needs to be kept cold, and that means it has to go in the fridge. So it may have made like an association with butter, or it just like is looking at something else and just saying that, oh, okay, this is very clearly goes over there. And we've seen, like say, others do that based on large LLMs where they were trained. Agility did that with the where they told to pick up the box that was the color of Darth Vader's sword. So it meant it had cultural references. It knew Darth Vader's lightsaber was red, and so it knew, oh, you mean the red box. So kind of going around and being very oblique about what your intent is to see how clever it is, and it kind of works it out. And so when you get systems that are that smart, they can generalize in a way on where items are supposed to go, because they can make a reasonably good guess based on what they've seen, even if they haven't seen it in the training set yet, and also figure out how to pick it up because they've seen other objects that are similar to that, not exactly the same thing, but it's like, oh, it's a bottle, I'll go over and I'll give it a try.
Wow, that's fascinating, because it's we humans, when we've not done something ever, you could still try and take an educated guess, right? You can make an educated guess about how, let's say you're trying to put something together, or let's say you just got something for IKEA, you don't have the manual, but you can kind of get an educated guess about how to put it together based on things that you've done in the past. So are we going to see emergent behavior at that also?
Yeah, it's pure pattern recognition. I mean, that's what we do, is we recognize certain patterns, and we like analogs. So whenever we're teaching someone a new concept they have never seen before, we use an analog that they're all familiar with, because that's the easiest way to teach. And so that's part of what's going on in the reasoning in here. And you will probably see some interesting emergent behaviors. It's like, undeniable that's going to happen. A lot of these LLMs have shown emergent behavior, and I think we'll see emergent behavior also coming from these bots eventually. I also suspect that at some point there's going to be this feedback loop that, as right now we are using humans to get these things to pick up boxes and move them around at the speed that the human can tele op. And we're trying to run the bot a little bit faster. And if we get a lot of successes of the bot going around doing this thing, why doesn't that become like a training set that can be used as like a force feedback for the next generation? So you go through and you curate all the ones that really went well, and you have that. And so literally at that point, the bots are kind of teaching themselves from the success of what's happened. And so there'll be a kind of reinforcement learning probably going on here as well, that you don't have to do the reinforcement learning in simulation. Why not do it in reality? Especially if you're going to deploy thousands of these bots and going to be running all day. I mean, it's like, my goodness, we're going to be collecting a lot of data here.
Yeah. And that just gets me thinking that if you're deploying fleets of these bots in different functions, and if you have a certain, again, through this process of reinforced learning, if you have, let's say, a new bot that's brought online, or they could be exchanging notes, so to speak,
yes,
training each other.
Yes. Or when, part of that might be local knowledge that you might want to have that somehow gets stored in either some prompts to let it know that oh yeah, this particular station over here has got some quirkiness about it. You might want to know. So there may be some way of being able to form it versus it generally going up to the overall fleet when it may not matter. So at some point, we're expecting our self-driving cars are going to know a little bit of knowledge about our local driving conditions, because the whole fleet doesn't know what's the best way to drive in and out of my driveway.
Sure.
It may want to generalize when it sees something like that, but for the most part, there may be something really peculiar about the way my driveway is or the way I like to do it, and I just like that to be saved.
Yeah, but isn't that the whole purpose of having a fleet where they're all talking to each other?
Yes. Yeah. And part of the fleet is like, when the cars are driving around, they're able to warn all the others that, hey, potholes over here or emergency vehicle or something like that. Yeah. And you would, you'd expect something like that, one of the bots upstream there on the conveyor system, if something is going wrong, might be able to warn the others, or like, there's a difficult to use package here, or things are like slowing down or backing up. So they would all be aware of kind of the problem, just like line workers would do right now. When there's an issue, they're going to shout to everyone, hey, we're having a problem over here at workstation 35.
Okay, Gustav, I'm sorry I cut you short earlier, but
It's fine.
Okay, so here's my question to you. Do you see any kind of everyday function that you cannot now? Because we've been talking about overthinking bots and the hand and overcomplicating the hand, right? You tend to think of it in a positive list. Let's look at a negative list, right? Let's flip it around. What immediately off the top of your head do you think a figure bot with this hand cannot do?
Yeah, so, I mean, as working in healthcare, I'm starting to thinking about those occasions, and maybe primarily
hand surgery.
And hand surgery, of course, yes, that will never happen. No, but I mean, maybe primarily like caretaking and putting in. Of course, you have probably good robotic hands that could put in a catheter or whatever, but I would not trust that hand to put on like the urine catheter or even the venous.
Neither would I.
No, but I mean,
having experienced a lot of oil changes myself.
Yeah. And I mean, like putting on a diaper on a child, or so it's probably not that far off, but there are some of these things that I think you need a little bit more dexterous hands, both from purely making it work to having it become comfortable, or having your patient or your elderly being relaxed in having the robot help you to help you out of the bed, or to I don't know, move the chair for you or anything. That's not a problem. But when it comes,
do you think fingertip sensors are going to solve that problem to some extent?
I think it will help. It might not be fully necessary, but I mean, reaching around, doing something behind the back of your patient, you might have to feel what you're doing, and might be enough with just the force feedback. But then also being on the recipient end of, I don't know, metallic fingertips, it's not that nice. So maybe we will become accustomed to it. But I think there are some of these, probably hundreds of different examples where it's not there yet.
Kind of tasks that are out of sight.
Yeah, exactly. So that's we saw it like pushing things away, but I mean, picking things up. Talked about it just previously with picking up things from your pocket, the pocket change or whatever, identifying it. And so within healthcare, definitely there is a lot of things that they could help with, and they could have humans doing the more human-to-human interactions where necessary, but it's not really there yet, I think. And then also, like, plumbing is always an example. I mean, certain reaching behind the sink and feeling the O-ring tightness or whatever, that I think might be a bit off.
The USB drive on your computer.
USB drive, exactly. And there you can kind of use certain knowledge about the computer and what the USB looked like before you moved your hand in there. So maybe you could, as you mentioned before, look up the blueprint for the computer and stick it in the right way. But yeah, things like that. I don't know. Would it be able to button up a shirt, this hand? I don't think so. Maybe, but that's really hard for us. Also, if we lose a little bit of sensation, you won't be able to button up your shirt or things like that. So
Okay.